Our revision will be based on the 2016 July paper. We're going to look at a few selected topics. To start with, we're going to look at an output analysis of a regression ANOVA table, where we're going to give an interpretation of the results that will be produced. So linear regression mainly looks at the relationship that exists between two variables, X and Y. And in the output, we are going to have three key things that you need to know. Number one, you will need to find the variable R, which will be the coefficient of correlation. Coefficient of correlation. This one will tell you whether the relationship is positive or negative. Then it will be the R square, which is the coefficient of determination. So the coefficient of correlation will just tell you whether there's a positive relationship or there's a negative relationship between the two variables. The R squared, if it is 0.9, it means 90% of X influences Y. In the regression equation, if it's a linear regression, it is given by B0 plus B1 X1 plus B2 X2 plus the error term if possible. This is a multilinear regression. The linear regression that we know, if it's one variable, it is given by B0 as B1 X1. So those of you who are familiar to this equation, which is given by A plus BX, it's just one and the same thing, where B0 is the intercept. So bit by bit, I want us to look at this and narrate it. So we've been given the R squared and the R. So we've been given to interpret our income and national data. So we're told that the business consultant hired your company and estimated the quantities of your major commodity Y, its price X1 and the consumer's income X2, and the national, using the national data from 2001 to 2004. So the regression data has been given below. So before we analyze any of the questions that are there, to start with, our R is positive, so it simply shows that the relationship that exists between the quantity demanded and the price and consumer income, and the consumer income is positive. Then R squared here simply tells you the extent to which X affects Y. So we're told that there is an 83% or 84% influence that X or the dependent variables have, the independent variables have over the dependent variables. So observations that we have in the data set are showing you that you have 14 observations. So the regression equation, like I said, if you have two variables, it is given by what? B0 plus B1 X1 plus B2 X2. So in this case, this is called the what? A y-intercept, which is a constant. And this is a variable 1, and this is another variable 2. So these are variables. So if we're going to look at our output, we can come up with a regression equation using these results. So y is equal to, what is our intercept? Which is given by 200 and what? 12.76. Then we also have variable 1, which is negative 13.146. So negative 13.146 x1 plus 0.005 x2. So this is our regression equation. This is our regression equation. So we are able to extract 4 things already here. Number 1, our R squared simply means 83% of X affects Y, or 83% of the independent variables affect the dependent variables. Our multiple R means the relationship is positive. And the coefficients here, we're able to come up with the regression equation where the intercept is 212.76 minus 13.146 plus 0.005. At that point, is there anyone who's behind?
Oh, wait, there's no part where you can raise your hands here. Okay. For me, I'm not getting it. How you're getting the identifying, and this is what you are getting. I'm kind of lost.
Let's go to our assignment, because funny enough, he may even bring your assignment to check the interpretation of your results. So your assignment was done using Stata, and you're being asked from here to come up with a regression equation. Now, the regression equation is given by the formula y is equal to a plus bx. So you can come up with a regression equation from this data that we've been given. From here, x is what? Coefficient of x is what? 3.53. And the constant is what? 7.6. So this you can write to a regression equation as 7.6 plus 3.53. So this output analysis is what your lecturer wants you to learn how to interpret the data. Okay. So it is very clear there. It's telling you what our value of x, the constant, and the variables. Okay. I want you to learn how to do the interpretation using the output. So I also used, that was Stata. I also use SPSS to find those results as well. So on the interpretation, what I'm trying to say is we can interpret our data from the output that has been produced. You'll be asked to interpret. Let me look at this summary output from SPSS. I want you to learn this from different perspectives. This that you're seeing here shows you the coefficients. Number 1, the coefficient of the intercept. Intercept means the constant. Number 2, it shows you the coefficient of any variable that you have. So we're given a question between advertising and sales. So you are asked to come up with number 1, the regression equation. Number 2, to identify which ones are our dependent variables and which ones are our independent variables. What are dependent variables and what are independent variables to start with?
Those that dependent on adverts.
What were you saying?
What was your question?
I was saying you need to identify your dependent variable and your independent variable. So dependent variable is the input. Independent variable, your dependent variable is your output, your independent
Okay,
variable.
so
So I was asking which
in
one?
this case, sales are dependent on advert.
Yes. So these ones are dependent. Then the independent variables are what? Your X, which is our advertisement. So you could manually be asked to calculate the regression equation, or the examiner will instead give you the output, which will look like this. Now this output is what you are learning how to read. Now get me clearly. There are a lot of variables that are here. Firstly, I want you to start with the easiest ones. I said R squared simply tells you how much of X affects Y. So the storyline of this output is that we've been given data set for 10 years that you have used to observe the sales being affected by the advertising campaign. We want to see how effective these advertising campaigns are on the sales. So we've been recording from 2001 to 2010. So these observations have given us 10 observations, and after inputting them, the output came out to be like this. Are we clear at this point? So using this output, number one, what can you make of this regression statistics? The regression statistics, number one, gives us the R squared, which gives us the extent to which advertising affects sales. So here our value, we've gotten 0.851, which means that 85.1% of what? Of the sales, 81.5% of the sales are because of advertising. Then our R, multiple R is a positive. It simply gives us that advertising influences sales positively. Are we together on these two R's?
I don't know how you're identifying multiple R as positive, because they all seem they are point something.
The multiple R can come out as negative or it can come out as positive. In this case, there's no sign. Whenever there's no sign, it's a positive R. Are we clear? Then we go to the intercepts here. The regression equation we know is given by Y is equal to A plus BX. So our A is called the Y-intercept. Our B, these are variables. So we can have X1 there, X2 there, or they'll put the actual variable which we're dealing with, which is advertising. So how do we come up with the regression equation here? This regression equation will be written as Y is equal to, the Y-intercept is 7.6, and our gradient or the slope is given by 3.533. So don't be shocked if your assignment comes, but the output has been given to you. You needed to know how to interpret this. Are we together? So using this output, we're being asked number
Okay, so
then we also have the ANOVA table here, where we have the sum of squares, the degree of freedom, the mean of squares, F calculated, and the significance test.
Mr. Collins, before you proceed,
Yes, sir.
on the just scroll up a bit. No, on the equation you've written.
Yes, sir.
Yes, this y is equal to 7.6. Is where are these figures coming from?
The coefficients here. The intercept is your A. So
Oh,
6
okay.
is here. Then your advertising is your B. Your slope is 5.3.
Okay.
Then you put 8
Okay.
in there.
Okay. All right.
Are we together on coming up with the regression equation?
Yes, it's clear.
I'm trying to reflect now on what you expect, because this is an exam which he set. So if it comes like this, you are now going to be asked for the given data above. Okay, what is the regression equation of x, y on x1 and x2? So you need to go here and interpret. Variable one, it can be advertising, it can be something else, but they're just general. So variable one is negative 13.146. Variable two is 0.05. So because I told you that for multiple regression, they're just adding the slope, slope one and slope for variable two. But the key thing is the intercept, you need to know that doesn't have a letter. So you start with the A, which is also given by B0. So 212, you put it there. Plus, this is negative 13.146. We put negative 13.146 x1 plus positive 0.05 x2. So this is a regression equation. Identifying that is simply 2 marks for just coming up with the equation, just from seeing, interpreting this. Are you together?
Hi, Collins. So the error part, you just ignore it. Or are there chances that you may be given also?
Which one? What do you mean the air part?
In the two variable equation,
Mhm.
yes, the error part.
He's talking of the standard
Because when you were
error.
explaining at first,
I'm moving step by step. For right now, I'm talking about how to come up with the regression equation. Is everyone okay?
Yes.
Okay. Number two, these two variables need to be tested in terms of significance. So to know whether they are significant enough to affect the regression equation, the p-value must be less than the percentage that we've been given, the alpha. So at 95%, our alpha is what? 0.05. So if the figure that you get as a p-value is smaller than this 0.05, then you know that the variable we are testing is significant. So when we go to the p-value here, so we're looking at variable one. Variable one is a 0 smaller than 0.05. Yes, it's smaller than 0.05. So the variable one is significant. Then the variable two, the p-value here is 0.818. Is it smaller or it's bigger than 0.05? It is larger. So this one is insignificant. So if you're testing this, you simply state that variable one has a significant, it's significant in short. It is significant to affect the regression equation. Then variable number two, you look at this figure here. Is it more or less than this? If it's more than that, it is not significant. So when you check this, you discover that this one is more than 0.05. The other way is to check the confidence interval. The confidence interval, if the test statistic is in between the significance interval there, then it is significant. Or if you check the confidence interval, there's a lower and the upper bound. If these two have a 0 in between, then it's not significant. So you can see negative 18 and negative 7. This one doesn't have a 0 in between. So this is a significant value. But if you check here, negative 0.04 and 0.05, one is negative and one is positive. Whenever you have such a situation, then know that the variable is not significant. So this is the only thing you needed to know. That's all. Those that are in my class, ANOVA and QM, I explained
I
this.
think just go back on the significance. The one where you are mentioning if it's less than 0.05.
Maybe this will confuse you. Let me look at the confidence interval. It seems to be easier for you. So where you have a confidence interval, we have three confidence intervals here, A, B, and C. So here we have 2,3. We have -2, -3. Here we have -2, +3. What is prominent about these three confidence intervals? That A and B are both on one side. These ones are positives and these are both negatives. There's no zero in between there. So these ones, we deem them to be what? Significant. Is that clear? They're significant enough to influence the regression equation. But for part C, you discover that one is negative and one is positive. So meaning the zero is capped in between. So whenever such a situation, there is an insignificant situation. So meaning the variable doesn't impact the regression equation in any way. Are we together on what I've just explained?
Yes.
Yes.
Okay. So with that being said, you can tell here that this is a lower bound and the upper bound. So the first one, obviously the intercept, we don't consider it as much, it's surely always significant. Both are positive, so that is significant. And variable one, they are both negatives. In short, whenever the signs are the same, it means it's significant. If the signs are not the same, it is insignificant. So you understand these are negatives. So this is significant, right? So variable one is significant. Then this one variable is negative, the other one is positive. So we can tell that this is what? Not significant. Are we together?
Yes.
All right. So from the data above, what is the estimated regression equation? Y on X1 and X2. I already told you. When they tell you to estimate Y on X, they're actually telling you to write down the regression equation. Then number 2, determine the statistical significance of the slope parameters estimated at 5%, 4 marks. So these are the slope parameters, variable 1 and variable 2. So variable 1 is significant because the 0 is not capped in the interval. Variable 2, however, is not significant because the 0 is capped in the interval. So you get your 4 marks for stating that. Are we together? Are we together?
What about the intercept?
They've just talked about the slopes. The intercept, like I said, we don't usually consider it. It is these two, the slopes, that we usually consider, because the intercept is always significant. So they're talking about the slopes, variable 1 and variable 2.
Okay.
Then now, the overall regression equation, the test rule is that we reject HO when our p-value is what? Is less than 0.05. Whenever we reject, then it is a good thing. So if you find the p-value in the ANOVA table being smaller than this, because the assumption is the p-value, we look at it from this angle here. So this is our 0.05. In short, if we have a number smaller than this, it's better. Which numbers are smaller than this? 0.00, 001, 002, all these are smaller than this. But if we had 0.1, 0.15, it's a bigger number than this. It means it's not significant. So when you look at this here, it is possible that variable 1 is significant and variable 2 is not significant. But the overall regression equation, the average, the aggregate, may be that the whole regression equation is not significant, or the whole regression equation is significant. By comparing the F table, this ANOVA tells you the whole picture of the regression equation. It is important when you're doing your research, like I mentioned today in class, that you need to start talking about research now, because all these courses are primarily preparing you to do research. So this is a p-value here. So at 5%, is this more than or less than 0.05? Because we've been given the percentage. Is this less than or more than 0.05? So this one is less than 0.05. That is a decision rule. So since the regression equation is less than 0.05, we declare that it is statistically significant, which is a good thing. It is statistically significant. Then they've asked you to comment on the unadjusted and adjusted coefficient of determination. So we have these adjusted coefficient of determination, which is R squared. So our R squared here implies that 83% of our X or our independent variables affect the dependent variables. That is for the unadjusted coefficient of determination. R squared is coefficient of determination. Where we have the adjusted coefficient of determination, it simply tells us that 80% of the dependent variables, which are X1 and X2, affect the regression at 80% or 81%, which is a good thing. This is very strong. So this was an econometric study. My concern primarily, because this was even more tougher, is on this one here, your assignment. So try to expect something like this, which is far easier. So like I said, now I'll ask you questions. What can you tell me about the significance of advertising at 5%?
Mr. Collins, just a minute on the reject PV less than 0.05.
Mhm.
Our F calculated was 0.00.
This one is a small number.
It was 0.00 something, yeah, which is less than 0.05. So you mentioned something about reject HO.
We always reject the HO if your p-value is less than 0.05. Okay, so this number is smaller, far smaller than 0.05. So we reject. Whenever we reject, it simply implies that there's a statistical significance of the regression equation. So meaning the regression equation is statistically significant. I hope this question won't be a compulsory question. All right.
I hope so too.
Yeah.
Even with one thing, because it's so I don't know, it's so difficult. You can't tell which numbers you're going to pick.
I think it's just something else. Maybe we revise on those ones that are better.
Mm-hmm.
Oh, I don't know whether you've gotten what I've explained is very straightforward. Okay, I don't know.
So Colin, you have really explained very well, but the challenge that we have is that we never touched this one and maybe we never understood it with
Came in your
the
assignment.
lecturer himself in class.
Yes, it came as an assignment. An assignment, that one, it was done by someone. And then when we didn't play full participation in the same assignment.
And even the lecturer himself, he never explained it fully. Let's face it, Mwevan.
But I've tried to
My
explain
mind is lost.
what you need to understand on this, because he
Hi,
like.
Collins.
Yes, sir.
I think we just need to understand this question because it may come. Because I remember you mentioned that if I gave you an assignment, then I meant that you should go and start it.
Yes.
So I can bring it.
Okay. So
Oh, definitely it's coming.